Hello, my dear children. Today we are going to discuss about type 2 sums. In the exercise 5.2, we are going to discuss type 2 sums. I have already told you this entire exercise is based on the concept of logarithmic differentiation. But there are only two types of sums will be there. Okay, my dear children, in the previous class, in the last class, we have discussed the first type of sums in finding the logarithmic differentiation, in which you get only one term. You get only one term on either side, either LHS or RHS. If you find there is one and only one term will be found. But here in the type 2, you get two or more terms. Two or more terms will be given on both sides or one side of an equation to find dy by dx. This is the difference here. Now let us see what are the sums in the exercise of type 2. See question number 4, question number 6, question number 7, question number 8, question number 9, question number 10, question number 11, question number 12. Especially question number 12 is the same as the example 33. You can refer example 33 while you are solving the question number 12. Okay, my dear children? Right. Now, I am explaining here question number 4. Differentiate x power x minus 2 power sin x with respect to x. Here we have to find dy by dx. We have to find the differentiation of this function. First and foremost step is we have to assume this given function is y. So y is equal to x power x minus 2 power sin x. For any question, first we write this step. Okay, my dear children, remember these steps, my dear children, while you are finding dy by dx in the type 2 questions. Okay, my dear children, let us consider this is equation 1. In this equation, if you observe, there are two terms in LHS. In RHS, there are two terms. X power x is one term, minus 2 power sin x is the second term. So in this case, we don't take directly logarithm on both sides. If there is only single term in LHS as well as RHS, then we can take the logarithm on both sides and we can follow the steps. We can move for further steps. But here there are two terms in RHS. So we don't take directly, immediately after this equation, we don't take log on both sides. Then what should we do? Here we have to assume x power x is equal to u and 2 power sin x is equal to v. We have to put x power x is equal to u and 2 power sin x is equal to v in this equation 1. Okay, my children, then we get y is equal to, we are assumed here x power x is equal to u and minus 2 power sin x is equal to v. So we get this equation. Okay, my children, then we differentiate with respect to x. Immediately after getting this equation, we have to write this sentence, differentiating with respect to x. Then what is the differential operator here? If we are differentiating any function with respect to x, what is the differential operator? Yes, dy by dx. So I wrote here d by dx. d by dx is the differential operator. So I wrote differential operator d by dx on both sides. So we get this step, d by dx of y is equal to d by dx of u minus v. Understood this step, my dear children? Right. This implies we get a dy by dx in LHS. Understood this LHS part, my dear children? Right. Is equal to d by dx of u minus d by dx of v. Because two terms are there, so we can find differentiation of the two terms separately. Okay, my dear children, that is why I wrote this part in RHS. Understood this part in RHS, my dear children? Right. Here because d by dx of y is equal to dy by dx. In LHS I wrote. That is why I wrote here reason. Understood, my dear children? Right. This implies dy by dx is equal to d by dx of u is equal to du by dx minus d by dx of v means dv by dx. Okay, my dear children. Now consider this is equation 2. Up to here we follow the steps. If there are two terms or more than two terms are there in a LHS or in RHS, we follow these steps. Understood these steps, my dear children? Right. Now we assumed here u is equal to x power x. So here we are finding these differentiation separately. That is why we have followed these steps. Okay, my dear children? Right. Now we take u is equal to x power x. Now immediately we can take log on both sides, because if we observe this equation in LHS only one term is there, in RHS also only one term, so we can take log on both sides. Understood, my dear children? We have converted this second type of function into type 1 function, type 1 questions. Okay, my dear children? Then we get log u is equal to log x power x. Understood this step, my dear children? Right. This implies log u is equal to x into log x, because we are using this logarithm property. What is this logarithm property? Log a power n is equal to n log a. Here a means x and n means x. So by using the logarithm property, I wrote this part. Understood this part in RHS, my dear children? Right. Now differentiating with respect to x. Hereafter, from this step onwards, we follow the steps what we followed in type 1. So here we follow the same steps. Remember that steps, my dear children. Recall that steps into your mind and follow the same steps here also. Okay, my dear children. So what is the differential operator here? D by dx, because we are differentiating the function with respect to x. So differential operator is d by dx. So I wrote d by dx on both sides. So d by dx of log u is equal to d by dx of x log x. Understood this step, my dear children? Right. This implies if you observe LHS, it is in the form of d by dx of log x. In your mind, assume this u as x. Okay, my dear children? Assume this u as x in your mind. Then it is in the form of d by dx of log x. Then what is the formula d by dx of log x? 1 by x. So 1 by x means u. You assumed u here as x in your mind. So 1 by u into d by dx of u. We are using here chain rule. Understood this part, my dear children? In LHS? Right. Is equal to, come to the RHS. If you observe this function, u into v or f of x into g of x, d by dx of f of x into g of x, means uv rule, product rule. Here we have to use product rule. So x f of x into d by dx of g of x means log x, plus g of x log x into d by dx of f of x means x. Understood this RHS part, my children? I used this d by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. This formula is called product rule. Do you remember this point, my children? Right. Again, d by dx of log x means 1 by x. In LHS, we used that formula. And also chain rule. Understood these steps, my children? Right. This implies 1 by u into du by dx is equal to x into d by dx of log x 1 by x plus log x into d by dx of x is equal to 1. Understood this step, my dear children? Right, because d by dx of u is equal to du by dx. and d by dx of log x is equal to 1 by x, and d by dx of x is equal to 1. We use these formula in this step. Okay, my dear children. Right. This implies 1 by u into du by dx. Understood LHS part, my dear children? Right. Is equal to, by simplifying this part, what will you get? X gets cancelled. What will be left here? 1. Understood this first term, my dear children? Right. Plus log x into 1. What will you get? Log x. Understood the second term, my dear children? Right. This implies d by dx, we are finding here du by dx. So du by dx is equal to u into, we are sending 1 by u to RHS. So it becomes u into 1 plus log x. Understood this step, my dear children? Right. This implies du by dx is equal to, what is meant by u here? X power x. So x power x into 1 plus log x. Assume this equation, assume this result as 3. Understood this step, my dear children? Right. Now we take second part. V is equal to 2 power sin x. V is equal to 2 power sin x. Here we have to find dv by dx. So to find dv by dx, we can use logarithmic differentiation also. But I used another method. Okay, my children, see here that I took differentiation on both sides with respect to x directly, because it is in the form of a power x. So I am using here a power x formula. Okay, my children, you can follow logarithmic differentiation also. Means you can take log on both sides, and after that applying the logarithm properties like this, you can find the dv by dx. Okay, my dear children. But I am here, I am using the alternate method. Okay, my dear children. See here, v is equal to 2 power sin x. If you observe this function, it is in the form of a power x. That is why I am not using here logarithmic differentiation. I am finding here dv by dx directly. So differentiating with respect to x. Okay, my children. Then what is the differential operator? D by dx. So I wrote d by dx on both sides. Understood this step, my children? Right. This implies d by dx of v. What is the d by dx of v? dv by dx. Understood LHS, my dear children? Right. Is equal to, now it is in the form of d by dx of a power x. Previously I told you it is in the form of d by dx of a power x. So I am using that formula. A power x into log a. A means here 2, x means here sin x. Okay, my children. So 2 power sin x into log 2 into d by dx of sin x. We are using here chain rule also, because it is not in the standard differentiation formula. In the place of x, sin x is there. So we are differentiating that sin x also, because d by dx of v is equal to dv by dx, and d by dx of a power x is equal to a power x into log a. And also we used here chain rule. Understood this step, my children? Right. This implies dv by dx is equal to, I wrote here constant numerical coefficient before the term, beginning of the term. So log 2 into 2 power sin x into d by dx of sin x is cos x. Understood this step, my children? Because d by dx of sin x is equal to cos x. We used this formula in this step. Okay, my children? Right. This implies dv by dx is equal to log 2 into 2 power sin x into cos x. Consider this is equation 4. So from the equations 2, 3 and 4, we get dy by dx is equal to x power x into 1 plus log x minus log 2 into 2 power sin x into cos x. This is the required differentiation of the given function. Understood, my children? Right.